Hello friends, welcome to the next problem of pushdown automata. Now this is again going to be a different type of problem. Rather, these will be the last two problems of pushdown automata and very critical problem to understand. Though they are very simple, let's get started and see how we can go about it. So friends, if you observe the problem, it says the language is L is equal to WCWR where W belongs to AB star. So AB star means W can have any combination of A and B, and WR is reverse of W. In other words, it is saying that I have to design a PDA for accepting odd palindromes with C as the central element. So for example, if I have W as ABA, my WR is going to be exactly vice versa, that is ABA. So the string will be ABA C ABA. Similarly, if my W is equal to AB AAB, so my WR in this case is going to be BAABA and the string will be ABAABC in between followed by BAABA, right? So all such strings should be accepted by my push down automata. Now what is the logic that we are going to devise? I say for each A, let's push one X. For each B, let's push one Y. Then after that, once you get a C, bypass it. And thereafter, for each B, pop one Y. For each A, pop one X. If it finally ends in epsilon, comma R, then it belongs to the language. So friends, let's write down the logic. I say for each A push one X, for each B push one Y, bypass the C. I'm not saying bypass first C because the rule says we are allowed only one C. So let us say bypass the C, and thereafter I say for each B pop one Y, and for each A pop one X, and that should help me in solving the problem. So now I'm not going to draw basic transition diagrams as I did before. We all know by common sense how to solve this problem. Let's directly start with the transition function. So let's get started. Now friends, over here the transition function is going to be huge, and that's quite obvious because we are almost at the end of the problem. So last two problems on PD are left, and it is quite obvious that they have to be the most difficult one. So let's get started with it. So now I have my del, and let me consider the string as A, maybe like B A A, C in between, A A B A, right? Okay, and let this be my stack with R. Now del, I'm in state Q0. I receive a input symbol A and my stack top is R. The logic says for each A push one X. Since push operation is going on, no state change is required, and over this R I'll be pushing a X. But my friends, we are talking of a palindrome and where W and WR are vice versa of each other. So I can also have my W as BAA. In that case, my WR will be AAB and the string will be BAA C AAB, and this also belongs to my language. So I have to ensure that this should also be accepted. And if this should be accepted, my friends, my input can also start with a B. That is what I want to make you understand over here. My input can start with B or it can start with A. So having looking at the transition function that we have designed till now, which says input is starting with A. But what if the input is starting with B? So we have to consider both the examples side by side and accordingly do the matching. So by now, your brain should be tuned to do all those things. So let me consider one more example. Maybe I have B, A, B, B, C, B, B, A, B. Again, a valid example. As a can come at the start when nothing is there on the stack and X was pushed. Similarly, I can also say that nothing was there onto the stack and a B comes into picture. And if that is the case, we have to repopulate this rule. I'm in state Q0. My input symbol is B. Stack top is R. Considering my second stack over here, I say you are in state Q0, remain in Q0, and over this Y, you are expected to push. And over this R, you are expected to push a Y. Right? So now this entire thing I can say this is for first A or B, whatever is received, these two lines are going to take care of that. Let's go ahead. Now my friends, if you observe the first stack, it has X at the top. If you observe the second stack, it has Y at the top. What does the first stack signify? The previous symbol was A, and the second stack signifies the previous symbol was B. Now, in the first stack, after this, either a can come or a B can come. So, in the first stack, if A comes, I'll be pushing a X. In the first stack, if a B comes after that, I'll be pushing a Y. And the same two cases will be working for my second stack also. So, let us consider that. Now, I say, this is one part. Going ahead, I say I'm in state Q0, my input is A and the stack top is X, one valid transition. And I can also say I am in Q0, my input is A, but my stack top is Y in consideration with stack 2, right? Also, I can also have I'm in state Q0, input symbol is B, and the stack top is X. That means in stack 1 a B comes now. Or I'm in state Q0, input is B and the stack top is Y. That is in stack 2 after a B one more B comes. So these are the four possible cases considering the two examples above. What is going to happen in all the cases? We are going to jot it down now. So now what is going to happen if I have a X and A comes over here? I simply say push operation was going on, let that be going on, and above this X push one more X. In this case, remain in state Q0. Above this X, since B came, push a Y. Similarly, in the third case, I have Q0. Above this Y, I'm going to push a X because A came into picture. And in my Q0 on B, above this Y, I'm going to push another Y because B came into the picture. So now I say, if I populate this in short, I say this can be anything, that is any A or B can be received. So let's consider over here. Let's say I'm considering the first example. A B comes over here, I push a Y on stack 1. Another A comes over here, I push X. Another A comes over here, I push X. So on and so forth till I get a C. Similarly for stack 2, I have A comes over here, I push X. B comes over here, I push Y. Another B comes over here, I push Y till I get the first C. So Till here my pushing operation is sorted. Now after this we are going to go to the input of C, and we know that we have to bypass the C. And how do we bypass the C? Simply by a state change. So I have in my state Q0, I am going to receive a input symbol C. But my friends, when I am receiving input symbol C, what could be the possible topmost symbol of the stack? It could be either X or Y, because anything could be there before C. As you can see in the first example, before C there was a, and in the second example before C there was a B. So the top symbol of the stack can be either capital X or capital Y. So that takes us across two cases, Q0C comma X, Q0C comma Y. And in both the cases I have to simply bypass the state. Therefore I write Q1 comma X, and here also I write Q1 comma X, right? So this logic is for bypassing the C just by having a simple state change. Now my friends, once we have bypassed the C, the logic says for every B pop 1 Y, for every A pop 1 X. Now my friends, over here when we are formulating the further part of the logic, as we had over here four cases, we are not going to have four cases after this. What could be the reason for this? The simple reason for this is, when I talk of an input like this, till the first part when the pushing was going on, my order was not important. Whereas when I am performing the pop operation, now I want the order to be exactly same as that of the push operations. That is, if there was a Y at the top, that signifies that after C compulsorily a B should come, right? So then only that palindrome matching can be done. So with this I say, let's go ahead. I'm in state Q1, input symbol is A and the stack top can be X, or I'm in state Q1, input symbol is B and the stack top can be Y. So in this particular case I say simply perform the pop operation, and here also perform the pop operation, right? Once both of these pop operations are performed, and if it finally goes and this is epsilon on R, I say accept the input. Therefore now you say Q1 on epsilon when the stack top is R goes to Q1, or rather say let's go to QF and R, and then we can have an example on this and check whether the things are going to work or not. However, we are very sure, understanding so many problems, that this logic is definitely going to work in this particular case. But if you look at the problem, introspect the problem more closely, still there is a small lacuna in the problem. What I mean by that? Now let me consider a very simple example. Friends, if I have my first example ABAA, C AABA, we know that this is going to work. If I consider my second example BABA, C ABAB, we know that this is also going to work. But the question over here says WCWR, okay, and my W is belonging to AB star. Now we all know by the definition of star, which is a Clean's closure, that star means zero or more repetitions. When I say zero or more repetitions, it is very much possible, highly possible, that my W is nothing but a empty string. So in that case, that would be epsilon dot C dot epsilon. So epsilon dot C dot epsilon is going to give me a single C, and I have to check whether my machine is able to accept the single C. What I mean over here is, let's check, is the machine able to do it. Now let's say I have a single C as input, So my input over here is simply a C alphabet. So I'll be starting in state Q0. My stack is going to be having R. So I should have something like Q0 comma C comma R. So Q0 comma C comma R, I do not have a state for it. Since I do not have a state for it, I have to make it because I have to ensure that this accepts. And that's the reason I leave space over here. So I say Q0 on C when the stack top is R. I should say please take me to state Q1 because I'm simply bypassing that C, and I say after taking me to Q1 do not touch anything on the stack. So now we know that I'm in state Q1, and after this I'll be compulsorily having a epsilon, and Q1 epsilon R as per the last rule is QF comma R. And now I say the machine's transition function is complete. So with this friends, we complete this problem. See you in the next problem. Thank you.